Okay, welcome to my session at Vox Bucharest, Wargames, Java vulnerabilities and why you should care. So, my name is Gerrit Grunwald, I'm working for Azul, we do JVMs. And I don't want to go into that, that's not interesting. So, I'm a developer, right? I'm not a security expert at all. But at this date, 24th of November 2021, we got this nice little thing called Log4Shell, right? So who was affected by that? Nice. Yes. So that made me think, because security for me, to be honest, I've never really cared about it. And when I recap, so I'm not that young anymore. And in the 20th century, even that sounds to me quite new, but it's not. Code was self-written and it was closed source, right? So, and source code was managed in a repository somewhere on a local server in your department. So really nothing very fancy that we have today. Everything was built manually. So you go to the office, tell the guy, oh, can you make a build? Okay, click, I do the build, no problem. And it was delivered on hardware, like USB sticks, if you have been fancy, or CDs or DVDs, or even worse, floppy disks in the past. Right? So, and everything ran on closed networks, local servers. That was fine. We had large monolithic systems, and only connected systems had the government, energy providers, or maybe banking. But that's it. In the end, we had the full control of the source code. Right? So every company has its own source code. It was under full control. And if we take a look at the 20th century vulnerabilities, then it was mainly password hacking or cracking, like brute force attacks to get into some systems. We had computer viruses, the first ones, spread via floppy disks or USB sticks because there was no download in the mid-20s. And then we had some early days of internet hacking. Oh, that's fine. And then time flies, and I realized, oh, it's already 21st century, damn it. These days, it's different. So we have a lot of open source software used everywhere. I mean, who's using open source software in his projects here? See, yeah, that's a huge difference. And we have distributed source code management systems. So you don't have to have it on your own server anymore. It's somewhere on the internet. We have automated builds like by CI/CD systems. The stuff is hosted in artifact repositories somewhere. It's running on public networks that are accessible from everywhere, in worst case. And you can access it via browsers or APIs, and everything is connected, right? And in the end, we don't have full control of the source code anymore. That's a fact. So in the meantime, there's a whole software supply chain that wasn't there in the last century. So in the end, of course, but not really all the time. So if we take a look at the 21st century vulnerabilities, then this is also different. Now we have malware and ransomware that's spread via emails, websites, pictures, you name it. So it's really crazy, even via mobile phones. Everything is connected, and everything that's connected will be hacked, you can be sure. If there is a way to hack it, it will be hacked. So spreading malicious code is way easier because of everything is connected these days. And the whole software supply chain is a target of these attacks, right? So and what drove me to that presentation was I stumbled upon all these different acronyms. You know, in the US, they have all these acronyms for everything. And I just heard that and I was like, oh my God, what's that? So let's start with CWE, which is Common Weakness Enumeration, right? So that means in principle, it's a community-developed list of software and hardware weakness types. Nothing you really need to know, but you might need to know these shortcuts and where you find it. So I put the links here, and I will probably give the slides to Andra after the presentation so that you can have all the links to this stuff where you can look it up. I won't go into details. It's just to let you know what it means. The next thing is NVD. It's the National Vulnerability Database. And it's something from the US government. And they just have a database where they keep all these vulnerabilities that they found and make it accessible to the public. So that means also to you guys, right? And to me. And They have a specific protocol which is called SCAP, Security Content Automation Protocol, to make that work. And you will find information here at this, the NIST, which is the National Institute of Standards and Technology in the US. CVSS, Common Vulnerability Severity Score. And we have two different kinds of that. And it's this first one that was version 2.0, and you see they had scores between 0 and 10. And the bad part with this one was that even if we have 0 score, it's still low in the severity, which doesn't really make sense, right? If there is nothing, it shouldn't be really low, it should be nothing. And they changed that, and they created the version 3. And you see 0 now is none, and then it starts with 0.1, and they also added critical in these scores. You will find these scores when you look up the next thing that I will tell you, which is CVE. It's Common Vulnerability and Exposure. And this stuff is the things that you find in the NVD, in the National Vulnerability Database. And this is in principle, the mission of that is to identify, define, and catalog publicly disclosed cybersecurity vulnerabilities. So that means if you look it up at the CVE.org, you will find stuff like Log4Shell, which has a CVE record, and this is CVE2023 44228. So if you look for vulnerabilities, you will find these kind of things, right? And then you can look it up in the NVD. If you search for that, they will give you some information about it, and you will find something like that. You don't have to read through that. It's just the definition for this Log4Shell issue, and it tells you the versions that are affected and that are not affected, and it also tells you what you can do or what was the vulnerability for this CVE. And all these things you can look up in the NVD, and you just need to know where to look for these things. And then this, for example, had the severity score in the old version. The 2.0 was 9.3 high, and the new one was critical 10. So it's just, you can find lists of vulnerabilities, you can filter for the severity, and then you can figure out if there is something that you are affected of or not. So that's just all these acronyms. Once I got that cleared, I asked myself, so what about Java? Is Java secure? So what do you think? Not? Okay. So there is a so-called OpenJDK vulnerability group, right? Which is it's a private forum, so that means you can't just go there and say, oh, I would like to be part of it, so they choose the people that are part of it. It's trusted members from the OpenJDK community. So they receive reports of vulnerabilities, right, in the OpenJDK code. And then they review these reports. They collaborate on fixing the issues. They don't fix the issues, right? They just collaborate on that. And they coordinate the release of such fixes, because this group of people, it's from different companies or individuals that work in the group, and the people who fix these issues could be providers of distributions, like let's say Oracle, Azure, Bellsoft, whoever. These guys can fix the issues that have been, now I'm out of my talk. So they can fix the issues that have been found and classified by this group. So they discuss OpenJDK security related issues, and they do not actively test this. So that means they identify, they take care that it will be fixed by someone else, but they don't really run tests on that source code and test if it's really now fixed or not. So this is up to the vendors that create the distributions. Then we have to take a look at the Java updates, because this is in the end the way how these fixes get into your Java distribution, right? So we have different parts. We have the so-called CPU, which is the critical patch update, and usually you won't find that. In the older versions of the Oracle JDK, you found, I think it was up to JDK 8, you found this stuff like JDK 8.0252 and 253, something like that. That was the CPU, and the other one was called PSU. What means CPU? Critical patch update means it contains fixes for vulnerabilities and for critical issues, which is vulnerabilities, more or less, right? So that means if you have a CPU, this is more or less safe to use in production, because it contains only fixes for vulnerabilities and critical issues. Then we have the PSU. This is the patch set update. And if you download the distribution from the internet, from whatever vendor, it's mainly this, right? It's not the CPU, usually not. And what this contains, it's a superset of the CPU. So that means it contains the CPU, plus it also contains fixes for non-critical issues, and it can contain new features. And you can imagine that if you implement new features with the PSU update, this could introduce new vulnerabilities. It's possible because it's a new feature, right? So that means with the PSU, if you have mission-critical stuff in production, you might want to be careful. So let's take a look at how this works, right? So you have these two releases. You have the PSU that contains the CPU, and you have the pure CPU update. So if we go to 1701, we have 4 times a year, we have these updates. Then with the next, with 1702, in the CPU, you get the fixes for the PSU from 1701. So you're always one step behind if you go with the CPU releases. With the advantage that you can make sure that it only contains the fixes, so no new features here. And that goes on for every release that we got in January, April, July, and October. So this is how it works. That's the way how these fixes get into the JDK that you download from the internet. So that means better stay up to date, because if you don't do that and you stay, for example, on 17.0, like nothing, just 17, there are a lot of issues coming into the JDK over time. And if you don't fix this, you really open up the doors for these vulnerabilities. So you just make sure you always stay up to date with this. That leads me to software supply chain. Software supply chain starts with us, with the developers. So we go into the development, we drag our stuff from a central repository like Maven Central, for example. Then we submit our code in our own Git repository somewhere. Then it gets into a CI/CD system where we have the build. Then this also drags stuff from the central repository. Then we build containers there. From there, it gets into an artifact repository, and this can go back to the central repository, right, to create the artifacts that others will use, and then from there it can get into production. This is in principle how it works. And this whole supply chain has a lot of areas where people can attack it. So I just give you some examples. So it can, for example, you can submit bad code, of course. You can compromise the repository itself. Or you can even build from malicious code here, build from malicious resources. You can compromise the build platform itself. Or you can, in this case, upload artifacts to the artifact repository. And so on and so on. You see, we have a lot of different things that can happen to this supply chain. And you're probably not aware of that because you are only here on the left side of the diagram. And once you put the stuff in the repository, at least for me, that was the fact in the past, I didn't care. Build it, ship it, security, I don't mind. So the vulnerabilities that we have here, for example, is if we go to this one, submit bad code, then a hacker can pretend to be a known contributor and submit bad code. That's one possibility, right? He can even take over a committer account and inject malicious code directly into the repository, which is also possible. Or what the next thing would be, he could retrieve passwords from build scripts. Who has passwords in build scripts? Because I saw that in production, I was really shocked. Sometimes you find these shell scripts and then, oh, there, look here, there are passwords in there. So this is, it's interesting. But yeah, you should take care about that stuff. If you run tests on each commit without having code reviews and stuff, there is a vulnerability here, right? You can imagine that if it just goes into the CI/CD system and you build it, you have no idea where that ends up. And if it wasn't reviewed, that's another source for a vulnerability here. And then in the end, a hacker can upload modified packages if they don't come from a trusted source, of course, or from a trusted build system in this case. And in the end, if you have websites that claim to be, for example, the Oracle website with a download link, and you download it from there without really checking, right, then this is, again, something where the supply chain has some vulnerabilities here. So that let's take a look at some facts that I found on the internet. This is taken from the Sonatype state of the software chain report. So over the past 3 years, the supply chain attacks had an increase about 742%, just for all these things that we saw. And another chart that I found on the NIST, which is the National Institute for Standard and Technology, you find this kind of graph where you see in the last years, there was a high increase in severity over time with vulnerabilities. You see, it's 20,142 vulnerabilities just in 2021. And this might not be the reality, because I think the last years that we see, maybe we just did better scanning. And then we figured out, oh, there have been more vulnerabilities. I could imagine that even before we had a higher number here. But this is the numbers that they put out. And another fact is that 6 out of 7 project vulnerabilities are coming from transient dependencies. So that means you have a library that you drag into your project, and this library has other dependencies that you have no idea where they come from. And they could have vulnerabilities inside, like Log4j, right? So, and again, this was taken from the Sonatype report, and they said 6 out of 7 project vulnerabilities are coming from transitive dependencies. So you should do something, right? And if we take a look at this open source thing that I mentioned in the beginning, that is now, as we saw, used everywhere, then you probably have seen something like this. That's a license agreement. You don't have to read through it, because the important parts are, is provided as is, without warranty of any kind. And it means that in no event shall the authors or copyright holders be liable for any claim, damages, or other liability. So what that means is, I owe you nothing. If you use this stuff, right, it's like this. You built your whole system on this teeny tiny library that's down there, that was supported by some guy somewhere who does that on his free time, but your whole stuff relies on that. So that means open source maintainers, they are not suppliers, right? So you don't have any business relationship with them. And that means if you use their stuff, you have to make sure that it's secure. You have to test it. You can't really say, oh, I download the library, so it's used everywhere, so it should be secure. It's up to you to do that. So the question is, what can we do? We as developers, what can we do? So we have different kinds of tools available that helps us here. So one is, for example, static code analysis, right? So what is it? So usually it's part of code review, like white box testing. It identifies vulnerabilities in your source code. So that means if you have your IDE, you can implement it there. So that means it's at the implementation phase, which makes it easy to fix stuff, because at this point in time, you have just access to the source code. And it's available as standalone tools, also as IDE plugins. And here is a list that I found, again, on this NIST website. That doesn't mean this is a complete list. And it also doesn't mean this is a good list. This is just a list that they came up with, and they said this is stuff that you can use. And you see there are free versions, there are versions you have to pay for, and quite popular ones are probably Sneakcode and SolarCube and others here. And there's also a free one, the Find Security Bugs. And if we take a look at this one, for example, you can find it here. Then we have some facts. It's free of charge. So if you like just to try this stuff, then just download this one, right? It is an extension of Spot Bugs, which is again an extension of Find Bugs. And it has more than 400 bug patterns that it supports. And there's a plugin available, and it looks like this, for example, as an Eclipse plugin. So you have some kind of a bug explorer there, and then it tells you, oh, this code might be a vulnerability, and it tells you why, and then you can fix it. So this is this thing, right? This is the Find Security Bugs. And then there are so-called vulnerability scanners. Similar, but they have more abilities. They can detect vulnerabilities by checking code or stuff against the database. Like, for example, against the NVD, right? You can do that. Or it can probe common vulnerabilities on your code and check if your code is vulnerable for this specific CVE. Then it can monitor misconfigurations or coding flaws, and it helps using only artifacts from reliable sources. So it can tell you, you know what, you have there a dependency, you download it from some private website. Maybe not the best idea. It can help using only artifacts with the latest secure version. So that means without known vulnerabilities. And they can monitor appearance of new packages with fixed vulnerabilities. That means if they find in your code base a dependency on a library that is outdated because there's already a fix, then they can point you to that. They can even help directly fixing that problem. And they can update dependencies as soon as new versions are available. So if we take a look at the software supply chain and then see how they work and in what places you can use them, then you can use them directly in development by scanning and fixing stuff here. They can monitor, scan and fix stuff directly on the repository. They can even help you with the CI/CD systems and scan, fix and monitor stuff there. And then of course there are scanners for artifact repositories and even in production, but that means most of the times that you have to run an agent to do that. So which is, I will come to that, because who knows what Java agents are? A few people, right? Yeah, this is the same, was the same for me. I knew where you can use them, but I didn't know how to use them for this kind of stuff. So if we have the JVM, then the JVM has different areas like the class loading system, the JVM memory and the execution engine. And then it also offers an instrumentation API. And then you can write an agent, and this agent can talk to this instrumentation API, right? This is the idea. And in case of these scanners, what they do is they have some kind of a callback. Every time a class is loaded, it will call the agent and tell the agent, oh, I loaded this class. So the agent can keep track of that. And you can imagine if you have a huge source code, then for every class that's loaded, it has to call the agent. So that comes with a performance hit of 10% and more. So that means if you run that in production, you need probably buy more cores or more nodes in your cloud environment to make that work. That's a little bit of a drawback here. Just to keep that in mind, it's possible to do that, but and to be honest, we talk to people that say, yeah, we could do it, but it's too expensive, and they don't do it. So let me ask you guys, who is doing vulnerability scanning in production here? 1, 2, 3. Yeah, it's not the majority. That's what I thought. That's also what we figured out. So there are different solutions who can do that. I mean, this is not only now for production scanning. This is the vulnerability scanners. So we have one, and Black Duck, X-Ray, again, Sneak, SolarCube, and there are many more that you can find. And you have sometimes you have free versions, sometimes you have paid versions, or both. It depends. And if we take a look at the Sneakcode stuff, for example, which is nice because you can download it for free and use it as an IDE plugin, then, like I said, it has a free and paid version. You can find it here. It supports more than 9 languages, which is great. And it has this developer-first approach, so that means it's made for us, not for some guys in the ops department. And you have a standalone version, and you have an IDE plugin. So you can just plug it into your IDE, and then you can use it from there. And it also has support for CI/CD integration. So a typical screenshot would look like this. That's what I found on their website. And if there's a better one, Brian might give me one. But this is the stuff that I found. So just to give you an idea how it works. So it gives you a detailed explanation of the vulnerability and all these things. It's quite helpful. The other one that I would like to mention is SolarCube. They also have this. It's an automatic code review tool. There's, again, a free and a paid version. 30+ languages support, more than 4,800 analysis rules, and it's also standalone and a plugin available. And again, it also comes with CI/CD integration. And it looks like this. It's in principle, it's very similar. I mean, what would you like to do, right? You have an IDE. It checks the code. It tells you the problems and helps you out of that. And then, of course, I have to do a product pitch because we also did that stuff. But our approach is a little bit different because what we do is we run only in production. And with this, we don't have this performance penalty because we build it into the JVM. So that means every time the JVM loads a class, it just checks against the web service if this class is vulnerable or not. And it's Java only, so it's not support for other languages. And we do fingerprinting CVEs, so that means we can figure out what is a CVE or not, and we have with this fewer false positives. The reason for that is we don't have a Java agent in this case, and because if the JVM is running and it loads classes, we can detect if this class is used or only loaded, right? So which is a difference. That means if you drag in a library and you have all these classes in there, it might be a vulnerable library, but it doesn't mean that this library is used by your code, right? But because the JVM knows what was loaded, we can detect that. This is the difference. And we don't use an agent for that because it's inbuilt in JVM. So that means we can figure out what is the problem, so what is loaded, is it vulnerable or not, and is it used or not? So we can get this kind of reports, and it just has an API. So we don't have an IDE plugin or something, so this is more meant to be integrated into other tools. So a secure software supply chain could then look like this. So you have a central repository, we saw that already, and usually there you can find stuff like Log4j, Spring, or whatever. And then you have third-party software on the right side that is also used in production, that is running on Java. And most people just, if you ask them, do you use Java? No, we use Kafka, we use Cassandra, but we don't use Java. So, okay, good to know. So they use Java without knowing that. And if we go to the development side, you see we can use these code scanners here, like the Sneak or Coverty or Contrast. And then in the CI, again, we have different tools that can do it here, can help you here, like Black Duck, again, Sneak or Coverty. And then if you have containers you would like to scan, I heard yesterday that also Sneak can do that, and Anchor and Aqua also can scan containers directly. And then we have, for example, our solution which can run in production. Because what we saw is many people use it on the left side of the diagram, but the more you go to the right side, it gets less and less that you find security scanners there, because people think, oh, we do it in CI/CD, no problem in production, which is not really true. So that was the reason why we created this tool. And last, I have a few words about shift left. You probably, who heard about shift left? A few, yeah, a few people, of course. We saw that diagram, and like I said, and it really, this is like I thought it was, because I never really thought about security in the past. Because security happened in the ops somewhere, right? These guys should take care about it, so I just write code. And the movement shift left means that the awareness of security issues should go more to the development side. That is the main idea. And if we take a look at the DevOps, which is now DevSecOps in the meantime, then we know this DevOps loop where we have planning, coding, and then building, goes over to release, deploy, and then operate, monitor, back to plan. So this is the DevOps loop, but security should be all over the place. So it shouldn't be just in one part of this diagram. So there's not really shift left in this case, right? So even if people say, well, the developers should do more, yes, probably they should do more, but security belongs to all these areas. And this is something that has to change. And if we ask the question, shift left, then yes, but also validate right? So this is what we try to solve with the production scanning, where we can make sure that not only if you scan in development, in CI/CD, your containers, you should also scan stuff in production to make sure you are on the safe side. So that means I'm way too fast, right? It's just 30 minutes, and this was 120 slides. The takeaway is, do you need to be a security expert? Probably not. But you need to be aware of the stuff that is out there, and that it's also your job to take care about security in your code base. Use all these tools. Just educate yourself by searching the internet. We have some experts in the audience over there who know about security. And with this, I would just say, stay secure. And if you have questions, I'm here to answer them, luckily. Thank you. I think there is a question. Yeah, so the question was how they come up with the CVSS scores, with the first version and the second version. So I just can guess, because the first version was the older one, and we saw in the diagram that in the past we didn't really have that many vulnerabilities monitored. And it seemed to be okay to start from 0 to 10 and just give it low, medium, high. And then they figured out that this curve really increased a lot, the number of vulnerabilities. And it doesn't, first of all, it doesn't make sense to have 0 as low vulnerability. There is no vulnerability. That's the reason why they put that out. And they figured out that it's not really, it should be more detailed, right? 3 levels is not enough with all these different vulnerabilities that we have. That was the reason why they invented the critical, which is just the upper limit of what's really affecting everyone like Log4j. Because in Germany, we have a news cast on the TV, which is every evening. I know it since I'm a kid. And Log4j was in that. I was like, wow. I never heard about something like that on the daily news, because that just shows how big it was, and this is really critical. And I think that's the reason they figured out. And if you take a look at the CVEs, they always have 2 scores. They have the old one and the new one. So which is a little bit strange, and I guess at some point they have to switch to the new one, but maybe because the old ones only have the 2.0 scores. I guess that's the reason. But that's all I know. Any other question? Yes. Mm-hmm. It calls, we have a service running on the cloud, and that means it will always, when it loads stuff, it will call this service where we have the fingerprints of the CVEs and will check against the service. That means it will take some time until you get the first report, right? So it's not live now, because it takes some time to call the service, check it, get back. But you get a report after a couple of minutes, let's say 10 minutes, you know everything that's loaded so far, and it will give you the list. So that's how it works. And we have, like I said, we have this website, but in principle, we don't have really a UI tool. We just have an API, because this is made to build it into other applications, because it's really only for production scanning. Yes? Yeah. It doesn't really ask for hard code. We do some fingerprinting on the methods, because all this stuff is done in the JVM anyway. So the JVM just calls our service with this specific ID, and there is something in between. So we have some kind of a forwarder that is installed, and it's talked. This is a service that's running in the cloud. Yes, that's where the processing and analysis of the data is taking place. Exactly. So we have a database in the cloud that we trained over the last year with all this stuff, and this is used to check against the vulnerabilities and give you this feedback. Yes, over there. That's a good question. In principle, it should be possible. Once you have the database on your server installed, then I don't see a reason why it should not run on-prem. But we didn't do that yet. So you mean if you have a closed environment somewhere where, yeah. Yes. So I'm pretty sure it would work, because I see no reason. You just have to make sure how to update the database on that server. But then, because it's just a web service that you start somewhere, you can also start it on a server in your own environment. Should work, yeah. Any other question? Then I gave you back 20, yeah. That's what you think, but it's not the case. So we made tests, and it's really, we can show that the difference is so minimal that you won't really feel it. It's below 1% of the performance that we really just, the question was, if we do this in production, that means the JVM has to do this additional work. what we do in principle, it's not that the JVM itself does the call. We have this forwarder, and it just tells the forwarder, this is the fingerprint. It's a very small thing. And then the forwarder do all the work and comes back to the JVM. So this is how it works. So it's not really that the JVM is calling somewhere a web service and get the results back and something. So it's all done by the forwarder. And this is also scalable, so you can have multiple forwarders and all that. So it's not, you don't have really an impact on performance because the JVM does that anyway. It loads the classes, we just fingerprint them and give them to the forwarder, and then the forwarder does the job. That's the idea. Yes? Oh, that's a good question. Why does this tool does not become a point of a vulnerability? Yeah, that's up to us to make sure that it doesn't become a point of vulnerability. So the JVM itself is not. It would be the forwarder one. But I just can tell you that we try to make it as secure as possible. But there's nothing specific we can do except of scanning, like using the same tools that we saw, and we do the same for this kind of stuff. Yeah. Anything else? If not, I would say enjoy the lunch break. Thank you.